It'll get to a point where having to draw a model every time, like a number line or charged field or chip model, it becomes very inefficient. So eventually we've got to move to where we can do the subtraction without having to draw a model. So I think the easiest way to subtract integers is to think of it as adding the opposite, because that's what subtraction is. The subtraction is really just negating or making an opposite. So think of subtraction as adding the opposite. Like if you can get that phrase in your head, it's going to help. And so what we're doing is like a little mental trick. We're going to turn the subtraction problem into an addition problem. And then you're like, oh, I know how to add, right? It's like a little mental trick. It's like, oh, subtraction is hard. Change it into addition. Addition is easier. So this theorem is what we're going to use for these problems. For all integers a and b, if you want to do a minus b, you can change that subtraction sign into adding the opposite. So like if you had 7 minus 5, you could change it into 7 plus the opposite of 5, which would be negative 5. So you see what I just did there? I just literally took the subtraction sign and I changed it to that, adding the opposite. And then it becomes an addition problem, and then you can use like the chip model, or you can think of it that way, or you can think about a number line in your head. But addition is inherently easier than subtraction. So it says work the following by rewriting the subtraction as addition. So adding the opposite, that's the phrase. So instead of 6 minus 7, I'm going to do 6 plus, what's the opposite of 7? It's negative 7. And if I have 6 and I add negative 7, 6 of those are going to cancel out these 6, and you're just going to be left with a negative 1. So you can think of it as, a number line or whatever you need to, but when you're adding these, the one that's farther from 0 is the negative, so he takes over. That's why the answer is negative. And these are 1 apart. Let's try another one. 9 minus 8. Change it to 9 plus the opposite of 8. So if you're at 9, think about a number line. If you're at 9 and you go back 8, you're going to end up at 1. You see how 9 is farther from 0 and it's positive, so it takes over, and the difference between 9 and 8 is 1. This is what we did in a previous video. How about the next one? Negative 8 minus 9. So it would be negative 8, change it to adding the opposite of 9. Now this one is negative 8 plus negative 9. So if you have negatives and you add more negatives, it's just going to keep getting negative. So this one's actually going to turn out to be negative 17. Like all those negatives combined together to make negative 17. And then the last one, 4 minus negative 10. Okay, so it's going to be 4 plus, what's the opposite of negative 10? Well, the opposite of negative 10 is positive 10. Do you see what just happened there? Now there's no negatives at all. Those two negatives made a positive. That's 14. That one's probably the easiest one on the page once you convert it to an addition problem. Let me show you a way that you can write this like a little bit of shorthand. Okay, so let me just kind of recopy these problems real quick over here on the side. Okay, here's how you can change them kind of quickly like I did up here. Take that minus, if you don't want to have to rewrite a separate line here, go plus a negative. That's 6 plus negative 7 plus a negative. 9 plus negative 8 plus a negative. Negative 8 plus negative 9. And now look at the last one. Plus, where you go, ding, ding. Just those two little negatives turned into a positive, and it becomes 4 plus 10. So if you'll do it this way, it's a little shorter way to write it, but it doesn't matter either way. And then make sure you can get the final answer also using the addition rule from before. So subtraction is adding the opposite. That's the easiest way to handle subtraction when you're dealing with integers specifically.